Hi, my name is Sangmin, and I'm going to tell you about pBox, a platform for privacy-preserving apps. So these days, smartphones are very popular, and one main reason is that there are so many apps that are running on these smartphones and provide very useful functionality. However, in order for them to function, they often need to access users' private data, and while most apps use this data responsibly, there also has been evidence of apps that misuse this user's data. For example, one report found that there are 300,000 apps was stealing users' personal data. And last year, a pet app, which has millions of users, was criticized for uploading users' contact list without users' consent. And there are, of course, many other examples of apps violating users' privacy. And this example indicates that the current approach to protecting users' privacy is not very effective. And one such approach is have users confirm which of their data the app is allowed to access at the installation time. And there are two big problems with this approach. The first one is this permission system itself is very complex. So according to the recent study, only 17% of users actually paid attention to while they are granting permission. And worse, only 3% of users correctly understood what those permission actually means. And the second problem is, once the user grants this permission, there is no guarantee on, no control on what this app would do with the given data. So therefore, the users implicitly have to trust this app publisher to handle their data properly. But the problem is, there are 300,000 app publishers out there, so it's very hard to decide which of these app publishers you can trust and which ones you cannot. So to solve this problem, we are going to shift this user's trust from these 300,000 app publishers to a few platform provider with well-known brand. And in fact, the user already have to trust this platform provider in order to use their device. And key to realizing this shift is a pBox. The pBox is a platform framework that allows users to use this untrusted app and while providing explicit and useful privacy guarantees. And to achieve this, pBox confines apps using sandbox to strongly protect the user's privacy, and at the same time, the platform pBox provides two platform-controlled channels, the aggregate channel and sharing channel, that allows apps to support more functionality while preserving users' privacy. So for the rest of this talk, I'm going to answer for a set of questions about pBox. So how are apps confined within the sandbox? And how does aggregate channel work? How does sharing channel work? And what privacy guarantee pBox provides to users? And then what's the applicability and overhead of pBox? First, let's see how pBox confines apps within sandbox. So in pBox, every app and every user is confined and isolated in their own separate sandbox. Therefore, apps running in this sandbox cannot leak users' private data outside of this sandbox. However, this also prevents this app from using the remote resource, which is often necessary for more computing power or larger storage. So therefore, pBox provides extended sandbox that spans both device and cloud service run by platform provider. So within this sandbox, while apps are still confined, apps can still use the resource from device and the cloud resources. And given this sandbox, pBox also provides two storage systems. First, it provides private vault, which is a private storage for every sandbox. So apps can use this private vault for storing user-specific data. For example, this map app can store user setting or search history in this private vault. On the other hand, this app also needs to store the app-specific data. For example, this map app needs to store its map data. However, storing this multiple copy of map data into private vault of every sandbox will be very inefficient. Therefore, pBox provides content storage, which is shared across all sandboxes, but expose only read-only access to such that it cannot be used as a communication channel among sandboxes. And given its sandbox, and along with these storage systems, pBox can support several simple apps, such as mapping app and simple media streaming app or password managers. So now I just described how apps are confined within the sandbox. Now I'm going to talk about how aggregate channel in pBox work. So aggregate statistics is useful for many app functionality. And for example, the supporting ad, which enables many free apps, requires app publisher to obtain aggregate view count for this ad. And to understand how pBox can support this aggregate statistics, let's walk through an example of how this view count could be tracked in the pBox. So to obtain this aggregate view count, app publisher would associate the setup counter with every ad and have this app instance to update these counters whenever this ad is shown to users. And then the app publisher will check this counter value periodically to learn about aggregate view counts for this ad. However, the problem is releasing this counter value, simply releasing this counter value to the app publisher can violate users' privacy because the malicious app can use this counter to signal users sensitive information. So to solve this problem, pBox used differential privacy to bound the information leak of individual users. So instead of simply releasing the counter value to the app publishers, aggregate channel add a random noise that is enough to hide single user's influence on these counters, and then release this noisy counter to the app publishers. So in this way, pBox can support this aggregate statistics without violating users' privacy. And in addition to this conventional differential private counter, pBox also supports the delayed output counter, which improves accuracy of infrequently updated counters, and top K counter, which allows app publishers to learn about the most frequently happening events. But because of the time limitation, I'm not going to talk about the details of them, so please refer to the paper for further detail. So now let's see how sharing channel in pBox works. The sharing is integral part of mobile apps. For example, even in this NSDI, you might want to share this beautiful scenery of Lombard, Illinois, with your family or your friend. However, the key challenge of sharing is to control what is shared and when it is shared and with whom it is shared. For example, a malicious app can share your credit card number with untrusted third party without your any consent. So pBox enables users to regain most of its lost control. And in particular, pBox enables users to control when it is shared, with whom it is shared. So whenever app attempts to share any data, pBox prompts the user with this dialog box and ask the user to specify the recipient of the sharing. In this way, user knows when and with whom this sharing occurs. And pBox also confirms this content being shared with the users. However, app can still embed the user's private data into these pictures, for example, using steganography. So user has less control on the what is being shared. However, with pBox, it is still very difficult for app publisher to directly access the user's private data because user always control the timing and the recipient of the sharing. So I just described the mechanism of the pBox. Now let's see what privacy guarantees the pBox can provide. So each of these mechanisms provides different guarantee with respect to privacy. So extensive sandbox provides strong confinement, and aggregation channel provide the bounded information leak, and sharing channel provide weaker guarantee of controlled sharing. And we can expose this different privacy guarantee to directly users. So based on the mechanism the app use, we categorize the app into one of the following. We classify the app into one of the following categories. So for those apps that use extended sandbox only, we classify them as a green app to signify there's no risk to users' privacy. And apps that also use aggregation channel, we classify them as a yellow to signify the minimal risk to the privacy. And lastly, the app also use this sharing channel. We classify them as a red app to warn user of potential information leak. So given these three colors, so when user use their device, pBox can provide explicit information about what privacy guarantee user can expect from this app, regardless where this app comes from. So now I'm going to talk about what's the applicability and overhead of the pBox. In particular, I'm going to focus on the following three questions. Can real app benefit from pBox? And how much implementation effort is needed to use pBox? And what's the overhead of using pBox? So this graph shows the number of free and paid top 10 apps from Google Play that can be secured using pBox. So main takeaway from this graph is the core functionality of bulk of paid app, about 74%, can be completely secured using pBox, as shown by this green graph. And similarly, a bulk of free app, about 67%, can be secured using pBox, as shown by the yellow bar graph. And note that the most free apps use aggregation channel to show ads, hence they can only be secured to the yellow level. And the study indicates that most of existing popular apps can be adopted to use pBox. And next, we try to understand the implementation effort in building new pBox apps. So we built following three apps: a password manager, and transcription app, and newsreader. So password manager use extended sandbox only. So we classified that app. pBox classified it as a green app, and transcription app has feedback mechanism, which use aggregate channel. So pBox classifies it as yellow app, and newsreader support both ad and sharing, such that pBox classifies it as red app. And to understand the overhead of porting existing apps, we ported two popular existing apps to use pBox. And as the number of changed lines indicate, which is less than 200 lines, the overhead of porting apps to pBox is small. And lastly, we consider the overhead of running pBox. So client overhead is not shown here because it's negligible, but at the server, we report two overhead. The first, our worst case overhead are bounded at 50%, obtained by issuing very small requests. And our overhead substantially reduced for more intensive workloads, such as calculating SHA-256 hash. So to summarize, pBox is a platform that protects users' privacy from untrusted apps, and pBox also provides explicit and simple privacy guarantee to the users. And this is the end of my talk, and I'm happy to take any question.
Hi, Feng from College of Vitaly. Very interesting work, and I have several questions about that. First thing is you said for your share channel, you have the user provide who and when we're going to share. Do you think it give you a lot of burden on the user side? So user have decide on each picture or each of the information they want to share?
So thank you. I think good question. And if I understand correctly, the question is the burden that user have to decide which picture has to be shared could be a big burden, right?
Yes, yes.
So the content, what is being shared is actually offered by app, and the pBox only confirms this content with the users. So it is true that whenever sharing occurs, user has to confirm it, but deciding what is being shared is done by app.
Okay. So in this case, for example, do you think the user have to have some expert knowledge to know whether or not they have the risk to share this something? And because, for example, if I have a covert channel in the system, for example, the two apps are include, and one is to have sensitive information and using covert channel inside the, for example, Android system to share the information using, let's say, the different CPU frequency, or using the side channel like the sound and the other channel to transfer the sensitive information to the other app. Do you think the pBox can defend against that?
Okay, the question is whether pBox can prevent malicious app to leak users' information using covert channel.
Yeah, I mean, there's a lot of different type of attacks, and for just the target on the private information. Do you think your skin already comprehensive enough to defend against covert channel? Just one example there, because it seems like you require user have some expert knowledge to know what to share and where to share.
Okay, so pBox design is also the answer is pBox design is also going to mechanism of implementing sandbox. So depending on implementation of sandbox, it is true that it might be vulnerable to covert attack using covert channel, but pBox design itself is also going to attack using covert channel. And if there's a sandbox implementation that is more resilient to this covert channel attack, pBox can still just use that sandbox mechanism to provide this explicit guarantee.
Okay, it's like a platform. You can use it. You can plug in other scheme to different attacks. Right?
Yeah, that's correct.
Okay, thank you.
Yeah, thank you.
Liang Zhang, come from Northeastern University. So nice work, I like it. So, but I have a concern. In the aggregation channel, you demonstrate that. Can you also aggregate, for example, I have a social network of myself, like what is my friends? Can your aggregation channel like tell whatever provider it is to, like what is my friends, how many of my friends, and how my friends intersect with another my friends, like have a differential privacy preserve of their friendship thing?
So differential.
So
okay.
I mean, can you protect the social network? Like, for example, I have my friendships, and then I want to share with the provider, or does your aggregation channel can preserve the privacy of such case? Okay, sorry. Maybe what else can you support in your aggregation channel?
Okay, yeah, that's a simpler question. So basically, aggregate channel, the main purpose of aggregate channel is provide aggregate statistics without violating users' privacy. So this one big example was supporting advertisement, and the other thing possibly we can use is some app, for example, music streaming app, might want to present what is the most top 10 popular music in the last 24 hours, and that we can support. And also the transcription app we built has a feedback mechanism. That what it does is, so whenever user speaks something, and app converts this to the text, and the app calculates the confidence score of how confident is app about this conversion, and then export to what is the most less confident word the app has. So you can export this confidence score to the app publisher so that they can improve their app after deploying this transcription app.
So for example, if I'm using Flickr, and then I have a close cluster of friends, and can these aggregation channels tell the app provider that you can sell some ads based on my friend set?
Oh yeah. So question is, can we support targeted advertising?
No, I have a social network, and then can your aggregation channels tell the app provider that maybe you might want to sell some car products to this group because he has lots of friends like cars?
So the guarantee of differential privacy is this app publisher can know the aggregate information, but it doesn't leak individual users' data. So because it adds a noise that is enough to hide the single users' influence on the output. So the differential privacy guarantee that app publisher cannot tell which user is in the data set or not.
Okay, great, thanks.
No problem.